morning, student. Now, next we will start in this video. We will start with the rest of the units of concentration. All these we have done: mass, percent, volume, ppm. Now, coming to molarity. What is molarity? Molarity is number of moles of solute divided by volume of solution, and volume of solution will be in liters. Clear? Number of moles of solute. For example, if we dissolve salt in water, then salt is solute and water is solvent. And by mixing both salt and water, resulting mixture is known as solute. So, number of moles of solute can be calculated. What is the formula? Formula for calculating number of moles. You have also studied earlier in 9th. Mass of solute in gram upon molar mass divided by volume of solution. Number of moles of solute कैलकुलेट करेंगे, जो भी आपका सल्यूट का मास दिया होगा उसको ग्राम में लेंगे डिवाइडेड बाय मोलर मास. फॉर एग्जांपल, इफ वी हैव गिवन 4 grams of NaOH. Clear? So this is solute, is dissolved in water. Water is solvent. Water is solvent. So 4 gram NaOH. Now we have to calculate, we have to put here number of moles of solute. So how to calculate the number of moles of solute? Mass of solute in gram. So mass of solute is given 4. That is 4 divided by molar mass of solute. What will be the molar mass of NaOH? That is, sodium is 23 plus oxygen is 16 plus hydrogen is 1. That is equal to 9. That is equal to 40. So molar mass is 40. That is equal to 0.1. 0.1 is number of moles of solute divided by volume of solution should be in liters. If in numerical volume of solution is given in ml, then change it in liter. Clear? Now coming to next we have molality. Next unit of concentration is molality, and how molality is represented by small m. And what is the formula? Number of moles of solute, same as in molarity, but here in denominator we have mass of solvent in kg, and in molarity we have volume of solution in liter, and here in molality we have mass of solvent in kg. If mass of solvent is in gram, then convert it into kg. Simply we have to multiply by 1000. So we can calculate number of moles of solute as we have the formula, divided by whatever mass of solvent is given, put that mass here. Next, this is an important question that we can be asked, that why molality of a solution is considered better or preferred for expressing the concentration of solution as compared to molarity. Simply, why molality is preferred over molarity? Because as we have seen, in molarity, in denominator we have volume, and in molarity we have mass. And volume, as we know, changes with temperature, and mass does not change with temperature. So it is easy to express the all the concentrations, clear, in molality, because the mass of solvent does not changes with temperature. Clear? Next is normality. What is normality? Normality is represented by capital N, and here the formula is gram equivalent of the solute divided by volume of solution in liters. Now we have already studied it. What is molarity? Molarity is number of moles of solute divided by volume of solution in liter. But here in normality, apart from number of moles of solute, we have gram equivalent of the solute, and we know how to calculate the number of moles of solute. Simply we have to take the mass of that solute, given mass of the solute, divided by molar mass. Same gram equivalent of solute can be calculated by mass of solute, as we have used in that calculation of number of moles, divided by equivalent mass. Clear? Gram equivalent can be calculated by mass of solute divided by, here we will take equivalent mass, and in case of number of moles we are taking instead of equivalent mass, we will taking molar mass. For gram equivalent, we will take here equivalent mass. So how we will calculate the equivalent mass? Suppose if we in the numerical we are dealing with acid, clear? Then the equivalent mass of acid is whatever acid is given to you. That suppose if we have given H2SO4, sulfuric acid, then how to calculate the equivalent mass of sulfuric acid? Simply calculate the molar mass of acid. Here sulfuric acid is 1 of hydrogen 2 plus sulfur 32 plus 16 into 464, that is 6, that is equal to 98 molar mass of sulfuric acid. That is 98 divided by basicity. Now basicity is in acid, here it is written divided by basicity. And what is basicity? Basicity is number of replaceable H positive ion. So here H positive ion are 2. So simply divide 98 by 2. That is 49. So equivalent mass of H2SO4 is 49. Suppose in numerical if we are dealing with base, and here we are required with equivalent mass of base. So simply write down molar mass of base divided by acidity, and acidity is number of replaceable OH negative ion. Suppose if we have NaOH, clear? The molar mass of NaOH is 40. Earlier we have done it, divided by acidity is number of replaceable hydroxide ion. Here hydroxide ion is 1. So equivalent mass, molar mass both are equal for NaOH. Suppose if we have a salt, then how to calculate the equivalent mass? Let us take one example. Suppose we have calcium chloride and we have to calculate the equivalent mass of calcium chloride. Then what we have to do is simply calculate the molar mass of salt divided by total positive charge on cation. Here cation is calcium. And what is the charge on cation? That calcium ion is 2. So simply we have to do is calculate the molar mass of salt. Suppose calcium is 40 plus chlorine is 35.5. So 2 into 35.5, that is 71. So it will be 1. 7 plus 4, 111. This will be the molar mass of salt divided by total positive charge. It means it is divided by 2. So the resulting will be 5, 10, 55.5. It will be the equivalent mass of salt. Same, if we have the some element, then simply divide atomic mass of that element with its valency. If we have iron, then simply write the formula mass of iron divided by the charge on that iron. These are some of the important units of concentration which you have to learn. You also have done all these in +1 also, but here it is required in +2 also. So I am just focusing it so that you can read it properly once again. This is molarity, normality. This is very much important. It will also help you in your practicals, how to calculate the equivalent mass. Okay, and here it is of my previous lecture. This. So thank you, students.